Okay, so how do we solve a problem like this? Well, the first strategy I would do is I would try to get to his try to get to these final reactants and try to get to these final products. And look at what you're starting with right here and see how you could possibly get to that point. So if I just look at this, I'm looking at the NH4 or NH3. There's 4 of the NH3s. So I know that there's going to have to be a lot of NH3s on this left-hand side of the reaction eventually. So what I'm thinking right now is I see this term right there, and I'm thinking, okay, that NH3, it needs to be on the other side. So I'm going to need to multiply this by -1. I'm going to need to multiply this, I should be more clear here, by -1 to get that NH3 onto this side. But that's not even enough. I need to get more than just 2 NH3. So I need to multiply this entire thing by -2. If I do that, that means I can rewrite this whole equation as 4 NH3. I'm just switching this around. That's going to be on the left-hand side now. Goes to 2 N2 plus 6 H2. Okay, that's what this equation is going to be now if I multiply it all by -2. Okay, so that takes care of this guy, right? That term right there. So far, so good. That's going to be right there. And I don't want to change this at all right now. Now I see 5 O2, and I want to try to get enough O2 on this side of the equation. So far I've got 1 O2 and 2 O2, and it's not clear how I'm going to get there. So I'm going to leave that O2 just as it is right now. I'm going to leave these as they are right now, because I could multiply this entire thing by 2 and multiply everything over here by 3, and that way I get 5O2. But it could be the other way around. I might need to multiply this bottom equation by 2 and this top equation by 3 to get 5O2. I don't know. So I'm just going to skip it for now because I think some other parts of this equation were going to show us the way. Okay, so now we look over here. We've got 4 NOs, and over here there's just 2 NOs. And there's no other NOs anywhere else in any of these equations. So that's a giveaway. That means that this whole thing needs to be multiplied by 2. If I multiply this whole thing by 2, that means it's no longer 2 right there, but it's going to be 4 right there. It's going to be 2 O2s and 2 N2s. Okay, so now that's taken care of. And since this whole thing is multiplied by 2, that must mean that over here, oh, that's our giveaway. This has got to be multiplied by 3 so we can get overall 5 O2s on the left-hand side of the equation. So I'm going to multiply everything by 3. So I'll multiply this by 3. And I'm just going to hope that this all works out. We'll double check in a second. So when I multiply this everything by 3, it's going to be not 2 anymore, but it's going to be 6. This is going to be 3. This is going to be 6. All right. And that's going to take care of our O2s. Now what about our H2Os? Our H2Os, there's 6 H2Os over there, and nothing else on this left-hand side that cancels it out. So it looks like we're in business. So that looks like it's going to be okay. Now I have to consider all the other terms that need to be canceled out. I'm going to use green to cancel them out. Okay, so I see over here, I see that there are 2 N2s on this left-hand side, and I want to cancel them out because they're not in the final equation that I'm interested in up here. So do I see any other N2s on the left-hand side? No. I see an N2 on the right-hand side. It's right here. And I've got 2 N2s on the right-hand side and no others. So that means I can cross it off. It is completely used up. It's in the reactant here and it's in the product here. So it's completely used up. So that drops out. Are there any other terms that drop off? I see H2 right over here. Here's H2. There's 6 H2s over here. Are there any other H2s on the left-hand side? No. Are there on the right-hand side? Yes, right there. I can cross them off. There's 6 of them there, 6 of them there. Okay, so it looks like we've crossed off all of our extra stuff here, and we're left with the final, on the left-hand side of the equation, we're left with 4 NH3s and 5 O2s, which is what we want. So we're good here. We're good there. And on the right-hand side of the equation, we've got 4 NOs, and we've got 6 H2Os, which is great here and great here. Oh, we're in business. So that's absolutely right. The right way to manipulate these sets of standard enthalpy equations. So now all I have to do is I have to figure out what each one of these terms is. If I have multiplied them correctly now, times 2, times negative 2, times 3, and I add all of them up, and I should get the right answer. So this kind of method is great if you are the kind of person who's really, really excited about standard kind of procedures and orders and so forth and puzzles. If you like that, you're going to love these kinds of problems because they make sense. You just have to kind of keep track of the details. So let's start off with our first equation, which is negative 180.5. We're going to multiply that by 2. And we're going to get negative 361. And that's going to be kilojoules. Now, 91.8 times 2 is going to be negative 183.6. And finally, 483.6 times 3, negative 483. Okay, it's going to be, oh, this is going to be a positive value. My bad, because this is a negative times a negative. I should have spotted that. Okay. The last one is going to be a negative 1450.8. Okay. So now I take negative 1450.8 and I add that to negative 361, and then I add a positive 183.6, and I'm going to get as an overall delta H. And now I add that kind of strangely. Negative 1,628.2 kilojoules. That is our delta H for this problem. I hope that made sense. All of the things that canceled out, why I decided to multiply them these certain ways. At the beginning, it was kind of a guess. I was hopeful, but then I went through methodically, and it turned out that if you go through methodically and check yourself, you'll be fine. So try that method for all the other problems. See if you get stuck. You can also, I should also say, besides multiplying these by whole numbers, you can multiply them by fractions like 0.5 if you want to. But what that does is then it changes the coefficient in front of all these terms right here. It halves them. So you can do that if you want to, but it's a little tricky. So good luck, and let me know if you have any problems.